You are so scared to answer this question. You're so scared to answer this question. If I put my singular apple on the table 1 times, how many times did I put the apple on the table?
Okay, 1 time.
Answer the question.
There's plenty of bodies of water that are absolutely level.
Okay. But there's not. So do waves not exist?
Well, there is, because tides don't exist everywhere either.
Okay. Where does tides not exist?
Tides don't exist on the Great Lakes.
So tides do exist on the Great Lakes. Did you know that?
No, they don't. They're not tides. They're caused by wind. It's wind swell.
Okay, so the Great Lakes do have tides, whereas one part will go higher than the other. Yes, it's caused by wind swell, but that also means that the Great Lakes are not flat, because they have this tide on there that is affected by this wind swell. Okay, so that's also not flat water.
Okay, so now we're in agreement that wind exists. So you're on your way to flat Earth. You believe in wind.
So now you're running away from the water. We've established that no water is flat, and now you want to go to wind. Okay? What about wind?
Okay. Okay, so if it's a globe, and the globe is spinning towards the east, right?
Okay.
Is that correct? Is that the correct rotation that you have in your globe model?
Sun rises in the east, so it's spinning to... It's spinning... Yeah, towards the east, yeah.
Towards the east, correct. Okay, so we're in agreement that's the globe model, that the Earth spins towards the east. Now you have to ask yourself a simple question. Which way, when you look in the sky, does the moon go?
It goes from east to west, because it rises in the east, sets in the west.
Yeah. Right. So,
so no.
What's your globey explanation of why that?
Let's see. Now I have to think. When we rotate, we're going west. We rotate west. That's why things rise from the east.
Well, we
rotate.
No, we rotate. We rotate east.
Nope. So when I'm standing
here,
we
rotate east.
Wait a second. When I'm standing here, and I am looking south, okay? Because I say south because that's actually what my position is right now. Sun rises over here on my left side. Okay? That means that's the east side. We are going towards the east. Yes, towards the east. You're right. Going east. Yeah. That's the way we're going. Okay. So what's wrong with what's
okay,
going
cool.
on?
I was gonna bring it up for you. Yeah, okay, so the Earth goes towards the east, right?
Right.
Okay. And the Earth is moving through the solar system around the sun in an eclipse, right? Or
ellipse.
An ellipse. Ellipse. So the Earth is moving around the sun in an ellipse. Now, which way is Earth going around the sun in the ellipse?
It's just going around. I'm not 100% sure even how to tell that to you.
It's going east also.
There's no east in...
So the Earth is going east around the sun.
There's only east on the planet.
East also,
when you're talking about the solar system, you can't say east. It's not correct.
Okay, so anyway, so which way is the moon going across the sky?
It goes from east to west.
Right, so how can the moon go west if the Earth is revolving to the east and it is going around the sun in an easterly fashion?
So again, going around the sun to an easterly fashion isn't a thing. That's not how it works.
Well, yeah, that's how it works. Because if you consider yourself looking above the solar system at the top of the Earth and the top of the sun, which way is the Earth going? It's either going in a counterclockwise or a clockwise motion. Which way is it?
I believe that it is a counterclockwise motion. Right?
Go look it up, bro. Watch.
And you're saying from the top, right?
Yeah, like if you were looking down on the solar system in the globe model.
Yeah, so it's a counterclockwise. Counterclockwise.
So that would mean the Earth is headed in an easterly fashion, right?
Again, saying easterly doesn't mean anything. We're going in a counterclockwise rotation. Because easterly, as to what reference point? Are you saying easterly, like if you were on the sun, which we're going to the east? Like using a cardinal direction for things not on the Earth doesn't make sense, because a cardinal direction is specifically a direction on the globe. So we are going.
I know what you're saying, but let me explain to you so you understand it. So if you're looking down on the globe, and the globe is making a revolution, which way is that revolution going? Draw the circle around the globe.
If I'm looking down at the globe, which way is the
it going counterclockwise, or is it going? Yeah, is it going counterclockwise or is it going clockwise?
Down, it is going counterclockwise.
Right, and so what direction does the Earth revolve?
So again,
towards the east or towards the west?
If you're trying to say that we move easternly around the sun, east is something that is only on the Earth. If you're trying to say the sun, then it is no longer east. Yes, absolutely. A cardinal direction only exists on the Earth. Yes, it does.
No,
yes, it does.
Look at stop remembering what textbook article you read that in for a second, and look down on the Earth.
Again,
which way does the Earth spin? It spins to the east.
Okay, so get to your point. You're playing semantics. Get to your point.
I'm not playing semantics. I'm just trying to get you to understand your model. Get to your point. That's all.
Get to your point. Land the plane. We've been talking about this for like 15 minutes.
The Earth revolves to the east.
Yep.
Yeah, the Earth revolves to the east. The Earth revolves around the sun to the east.
Nope, that's not
Which way does the sun go when you look at it?
That is not a correct statement, dude.
Not the sun, I'm sorry, the moon.
So everything in the sky
rotates
east to west.
The Earth revolves around the sun clockwise. You're playing semantics. The Earth revolves around the sun clockwise.
Counterclockwise.
The Earth revolves clockwise. Is that a true statement? I'm sorry, counterclockwise. Correct. Yes.
Yes. They both.
So both go counterclockwise.
As we're going around the sun, it's also rotating. Yes, that is correct.
Right.
Now get to the point.
But for some reason, you're not able to call that direction east in space.
15 minutes. Get to the point.
Right. Anyways, so they both go the same direction, right? But the moon doesn't go that direction when you look at it.
Right, because when you rotate, everything goes opposite the direction you rotate. If you're rotating left to right, everything's going to move past you right to left. If you're rotating left to right,
so
it's going to
when
come
they say
right over your right shoulder.
Right. So when they say that the moon is moving at 2,200 miles an hour across the sky, would you be someone that believed in that statement?
Wait, get to your point with the other thing. You're hopping to a different topic. Get to your point about the rotations.
We just had to get through the rotation that everything goes to the east except for the moon, which goes to the west.
That's 0 point to what you were just saying. Now let's talk about the speed of the moon. Since you didn't have a point to... You ran away from the water being level thing once I started questioning you on what water. You're running away from the directions that things are rotating. Let's go to the speed of the moon.
I'm not trying to get you lost in the weeds here. I'm not trying to get you lost in the weeds. Listen,
that's why you argue
trying
about
to make
east
a
to
point.
west for like 5 minutes.
Okay, no, but I'm trying to make a point.
Make your point.
I'm trying to explain to the audience Globe model, which is really hard to remember what it is. Okay, and when we finally came to agreement, except for there's a little nuance as to whether the solar system moves east or not. But that said, we did agree that they both move counterclockwise, and then the next thing was that the moon goes to the west because of the rotation of the Earth. Okay, so that's the Globe model, and I took 15 minutes to agree on something.
Holy crap.
So, the moon moves in the sky at, the moon moves in the sky at 2,200 miles per hour. Right? So, under Globe math, it's already off by the 1,000 miles per hour that the Earth is moving.
So here, let's talk about sizes of circles. So we have an inside circle and we have an outside circle, correct?
Yeah, the outside moves faster than the inside.
Correct. And if they're staying together, the outside moves faster than the inside, right? So there's your discrepancy.
Right. That's not what I'm talking about.
Right. Okay, so then what are you talking about?
I'm talking about the fact that when we measure that shit up in the sky, that baked into the cake, just like baked into everything about your philosophy about the moon, the stars, and the shape of the solar system, it's all been programmed. It's been reverse engineered, right? So they've made the math fit the solar system, so to say. So there's going to be a lot of problems with it that don't work out. And so if you're going to come up here and say the flat Earth is bullshit,
you haven't said any problems yet. You've just
there's
circles.
a big one right there.
What problem? Where was the problem?
The very first one is that our judgment of speed is wrong. So if we say the moon's moving at 2,200 miles an hour through the sky, and then we apply that speed to Earth, it's not going to be the same thing, because our judgment of that speed in the sky includes the revolving of the Earth.
When you say in the sky, you're saying when we look at it, we measure how fast it's going like this? Is that what you're thinking? No, that's not what that measurement is. So when we go and measure it through the sky, we cannot measure that in miles per hour because that is an inaccurate measurement. What you are thinking is here's the Earth, and the moon goes like this, and this speed right here is at 2,200, whatever speed you were just talking about, okay? This speed right here has nothing to do...
It's at 2,200 miles an hour. Okay, it's a scientific fact.
Then it has nothing to do with how fast it moves through the sky. How fast it moves through the sky is in relation to our rotational speed. How fast the Earth itself, is spinning.
Okay, so, what I'm saying is that if you take a speed measurement, like if I'm in Los Angeles and I take a picture of the moon, right, and I make sure it's in the same sky that my brother takes a picture of the moon in Nashville, and he takes a picture of the moon 1 hour later, and the rotation of the actual moon itself is exactly the same, then that proves that its speed across the sky is 2,200 miles an hour, and that is an accurate fact.
That doesn't measure its speed.
It will measure its speed because you look at how many miles it is from.
It moves through how many degrees per
but
hour.
It's still 2,000 miles.
That is incorrect.
But it's 2,000 miles. Listen, bro.
You can't measure
the speed. 2,000 miles from here to Nashville.
You cannot measure the speed of the moon that way.
It's 2,000 miles from here to Nashville, bro.
You said that.
I know. Times. Yeah, you can. You can. You absolutely can.
So yeah,
absolutely can. You can measure the speed of the sky.
So if me and someone 2,000 miles away take a picture of the moon, then we have measured the speed of the moon?
How do you think you get the speed of the International Space Station?
Its own speed on how fast it's going around the Earth. We don't sit here and measure. We can measure... Wait a second, hang on. We can measure how many degrees it's moving through the sky, and we can say, okay, in 1 hour, and actually it would say in 5 minutes we've measured that it moved 17 degrees. We know that the height of the ISS is this much. And from so we're creating an angle here. Okay, we know that At this point, it was here, and then 15 minutes later, it was here. Okay, we now have an angle right here. We know these two sides. Okay, that means that we can solve for the distance of this side of the triangle. That is how we figure out how fast something is moving through the sky. So if you are simultaneously taking the picture at 2 points on Earth, that doesn't actually measure how fast the moon is moving. You would have to stay in the same spot, take a picture, or take the angle to the moon, wait, take another angle to the moon, and then use Pythagorean theorem to figure out the distance that it has traveled in that time. You also have to factor in the motion of the Earth within that time and subtract it from those angles. It gets pretty complicated when you get into the accuracy of it.
Okay, well, what you just said there is you have to take the motion of the Earth out of the equation. And that's exactly my point, so you're agreeing with me.
No, I didn't say that. You have to account for the motion of the Earth. Do not lie about what I said. I said you have to take into account that you have moved in that little bit of time. And if you do not take that into account, your measurement will be off, giving you an inaccurate distance that the moon is traveling.
Thank you. That was my whole point. That was exactly my point. Is that whenever they tell you the speed of the Earth,
that absolutely was not your point at all, because you tried to say someone 2,000 miles away, and now you are running away from that and grabbing onto something that you think is the point.
You're not running away.
Yes, you did. Then why does someone have to be in Nashville?
That's the point.
Why does someone have to be in Nashville?
Is that the?
Why does someone have to be in the other?
Because that's an actual observable thing.
Okay, so
it's distance 2,000 miles.
Okay, we don't, but like I said, you don't need that. That does nothing for you.
Why not?
I've just explained it, dude.
If you want to track how fast the moon moves across the sky, then you absolutely need to know the distance on the ground.
No.
That is absolutely a thing you need, sir.
No, that isn't.
Yes, you do.
No.
Yeah, you have to make a triangle between the Earth and the heavenly body that's moving across the sky in order to judge its distance.
You're talking about parallax. You do need that in order to see. Yes, you are talking about that is not speed at all. That parallax doesn't get you the speed of anything.
Okay, well, if you Google the speed of the moon across the sky, what does it say?
Were you talking about parallax?
Do you agree with what
yes
Google
or no?
says,
Were you talking about parallax?
Do you have some knowledge is greater than Google? Is your knowledge greater than Google? That's what I'm asking you.
Were you talking about parallax? Yes.
It is. Your knowledge is greater than Google.
Yes or no?
I was talking about the solar system and parallax and many different things. Yes.
Parallax. Okay. So parallax does not measure how fast something is moving. Parallax only measures how far away something is from you. So you have two observers simultaneously, like you said, look at the single object. Okay? You have to know the distance between them. And then what is the other thing that they have to measure? Do you know?
The angle.
Yes, the angle. Up, right? So you have to know the distance between the two, and then you have to measure the angle up to the moon. Okay? Now, in no way can that be used to measure the speed that the moon is moving.
Okay, that's fine, but my point is that all these things are used in order to
because your point was
give us the truth. And if you're going to deny things,
I haven't denied anything.
If you're going to deny the distance between two cities,
I didn't deny that.
You're denying geography.
I didn't deny the distance between two cities, bro.
But you're saying that it's not 2,000 miles from Los Angeles to Nashville.
I never said that once in my life. I have no idea the distance between those two cities.
You think that's a true statement?
Never have I ever said that.
Would you say this from the sound of my voice that that's a true statement?
I don't know. I can.
Would you trust?
I'll take your word
for it.
I've never said the opposite. For you to say that I said the opposite would be either misinformed or you misunderstood what I was saying, or you're lying. So which was it? Did you misunderstand?
All right, fair enough. Not, and I am misunderstanding you, because that's where it sounds like you're going.
Okay. Yeah, I don't know the distance between those two cities. I wouldn't try to tell you that that's wrong. I am okay with just assuming that you're correct on those two, with that distance.
Yeah. So, I mean, if you look at it geographically, you have to measure the distance between the two cities.
Correct.
If you're going to look at the moon and go, how fast is it going, bro?
Nope, you cannot use parallax.
And if it matches up to what the speed that they tell
you cannot use parallax to measure how fast. You cannot use parallax to measure how fast the moon is going. You do not need to use two cities to do that. In fact, if you're trying to use parallax to measure how fast something is going, you're doing something incorrect. So try again and tell me what your problem is.
I'm telling you that if I travel from here to Nashville in 46 minutes, that I was traveling at 2,200 miles an hour, approximately. The same speed that the moon is quoted by Google.
What in the world does that have to do with the moon? What in the world does that have to do with the moon?
That's a way you can do a real world observation that proves it's a flat Earth.
Again, are you trying to use parallax to measure how fast the moon is going? Yes or no?
For purposes of your discussion,
yes
let's say
or
no,
no.
Because I don't want to waste any more time on that.
Yes or no? Are you
said
trying?
No.
Okay,
yes,
great.
I know.
You said no. Okay, so now try and tell me why the speed of the moon has anything to do with the distance between wherever and Nashville.
Because the speed of the moon is what you can measure it moving across the sky.
Not from those two locations. You can't, because you're trying to use parallax. You already said you were not going to try and use parallax to measure the speed of the moon. So, what does the speed of the moon have to do with those two locations? Because it's definitely not what you're saying, because you said you're not trying to use parallax, but if you're trying to use those two locations, you're trying to use parallax.
Okay, so if I take off in a plane at LAX and I arrive in Nashville an hour later and it's 2,000 miles apart, how fast did I go?
2,000 miles per hour, but that has nothing to do with the moon. We've already established. Stop talking. We've already established that is the distance between those two cities. It has nothing to do with anything. You keep saying, well, if you take off and if you travel in an hour between the... No, I don't care how far is between them. 2,000, great. You keep trying to prove that they're 2,000 miles apart. That has nothing to do with the moon. You cannot use that to measure the speed at which the moon moves. It cannot be done.
Why?
Because you're trying to use parallax.
Okay, so why can't I do it?
Because there's no way to do it. So when you're at one city and you look at the moon, and you're at the other city and you look at the moon, and you know the distance between them, and you get the angle to the moon, what are you finding?
The moon's at 12 o'clock in both cities.
That wasn't what I asked. What is the measurement
I know,
that you're
but I'm telling
taking
you
when
you're at our experiment?
When you so at
when the
12,
moon's at 12 o'clock.
At 12 o'clock means nothing. I know. At 12 o'clock means nothing. It just means that it was in the direction that you are facing.
At 12 o'clock.
Was it north? Was it what angle in the sky? Because at 12 o'clock isn't a measurement. Because my finger.
Oh no,
I forgot.
I forgot the other part of the equation.
It is still at 12 o'clock.
I'm sorry. I'm sorry.
Wow, I've been sitting here for 10 minutes telling you that that's the wrong equation. Okay, go for it.
Yeah, so the latitude's the same on both cities. Okay, it's only off by 2 degrees. That's it.
You're still talking about parallax.
We're both looking in the exact same direction in the sky.
What did you use to measure the angle?
We're both looking in the exact same direction of the sky at the same time in the sky.
What did you use to measure the angle of the height? You use telescopes? Telescopes don't measure angles.
Yeah. Okay, but both use telescopes and use compasses for the direction that the telescope was aiming at.
And what was the measurement that you got?
And then on top of that, I don't remember off the top of my head right now, but on top of that, the actual orientation of the moon is exactly the same.
Correct. Yes.
Because if it wasn't exactly the same, then that would say that we were either off or the speed of the moon was off. But instead, the advertised speed of the moon came directly nuts on, just like the Globey model says it does.
How did you calculate the speed using? How did you use what you observed to calculate the speed? Go for it.
Because the pictures were taken 43 minutes apart, and the distance is 2,000 miles.
You didn't even take the pictures at the same time?
But the speed of the moon is 2,200. So no, they were taken 43 minutes apart. Otherwise, you wouldn't get the correct orientation on the moon. The moon would look tilted one way or to the other, depending on where you're taking the shot at.
So you weren't in the same place. You didn't
Plus, you wouldn't be able to get the moon in the same position in the sky.
Okay, so the first time you said it, you said simultaneously. So now we're dealing with something different. Okay, so
if I said simultaneously, I apologize. It was not simultaneously. Although I have done that.
So
I know, but I've done the simultaneous one, and the moon, the orientation comes out different. When we do simultaneous pictures, the moon orientation is different.
The simultaneous one is called parallax. That's what you said you were doing. And then you changed it and said that they were 40. Yes, you did. And then you changed it and said that they were 43 minutes apart. That's the first time you've said 43 minutes apart. So now that you have waited an amount of time, hang on.
Talking about the orientation of the camera.
I don't care anything about the orientation of the camera. I don't know why you would think that. I haven't talked about the orientation of the camera whatsoever. So when you have taken it 43, because you have waited 43 minutes to take the second picture. I mean, you can't measure anything based off of a picture only. You have to take some other measurement. So a picture is not what you used. But because of that, you could, in theory, measure the speed of the moon. That's absolutely correct. That's fine. Because you waited an amount of time. Because remember, speed is distance over time. And so if you are waiting an amount of time, measuring again, that is distance over time. However, you're not measuring the physical speed of the moon. You're measuring how fast it moves through the sky.
Right. And which brings me to my point, which is the math is already baked into your system, bro.
So wait a second.
The rotation of the Earth is already baked into all.
Wait. So I've heard this argument before that the flat Earth is baked into the globe. Now, question: if the Earth were a globe, wouldn't it turn out the same? Because it's weird that everything works on a globe, and you can just say, "Oh well, you just magicked it into a globe," but you can't actually show how it's been magicked into the globe, especially when we have to account for things like rotational speed and curvature.
Right. So here's what you do, bro, is you take your degrees in the sky, right, and you see how fast the moon moves using degrees and figure that out, right? And then you take those same degrees and you put them on Earth. Yeah, then you put it on Earth. If it's the same speed...
What do you mean put it on Earth? What does that mean?
You'd have to put something on Earth that moves as fast as the moon, 2,200 miles per hour, or 2 times the speed of sound.
No, you don't.
Yeah, you do. You do. And you put something on Earth that moves 2 times the speed of sound. Listen, bro. And then you put that thing on wheels, and you put it out in a big giant salt flats, and you shoot it off, in one time going east and one time going west, and you measure what you get. And then you're going to be able to tell if it's a globe or not. And then the argument's over. What do you mean
measure what you get? Measure what you get what?
Measure what the speed is that you get on the device.
So you're saying that the ground speed is 2,200, and you send it west at 2,200 miles an hour, and then you send it east at 2,200 miles an hour, and then you measure its speed?
Yeah.
It's going to be 200 miles.
Yeah, you measure its speed, so you say how long...
It's going to be 2,200 miles.
How long does it take to get 10 miles? After it gets up to speed, how long does it take to do 10 miles?
Is it
and
connected
then you could just
to
do the
the
math
Earth?
on it.
Is it connected to the Earth? Yes or no?
Yeah, it's on
Great.
wheels
Then the
connected
rotation
to
of
the
the
Earth.
Earth doesn't matter for this experiment.
It has to.
Nope. Because it is connected
It
to
has
the
to.
Earth.
It's the same thing
No,
in the Earth.
listen to the explanation before you start talking. Because it is connected to the Earth, that means that it is within the same reference frame of the Earth. And as if you are on the Earth measuring, you're also on that reference frame. So what is going on here? And you are on a train. This train is moving 100 miles per hour forward. Okay. Now, I'm going to tell someone to run from the back of the cabin to the front of the cabin and time them. Then I'm going to tell them to run from the front of the cabin to the back of the cabin and time them. They went the same. They went the same distance, and it took them the same amount of time. Are we still going 100 miles an hour forward? This is the same
Yeah,
concept.
no, I understand that argument.
Yep.
I totally understand that argument.
Same
Yeah, I
concept
understand that
of
argument.
having a ground-based object doing this experiment. You're going to run into the same problem as if you were in a plane doing the same thing, because the atmosphere rotates with the Earth. You are within the same reference frame of the Earth. And according to the way that physics works and reference frames work, you cannot use that to measure something outside of the reference frame, which would be your own motion, the motion of the reference. You cannot measure the motion of a reference frame from within the reference frame.
Okay, so what you're saying is the core of the Earth is spinning around extremely fast.
Nope, that's not what I said at all. I never talked about the core of the Earth in the slightest.
Because the way I visualize it is, if it was a hamster on a wheel, the layman's version would work, and it would be harder for the hamster to go against the rotation of the wheel. But the way that you explain it is the thing that's below the wheel is spinning so fast that it makes the track on top of it not seem to be spinning at all to the hamster, because it's always moving.
That's not what I said in the slightest.
Yeah.
No.
And the way you described it, where the train was in a straight line too, it wasn't in a curve like going around a ball, was it? You described it in a straight line.
That has nothing to do with that has nothing to do with the example.
Yeah, I think it does, bro. I think it does.
Bro, it does not. And now you've
skipped
now over to a different... Wait a second. So you've hopped and skipped away from the speed of the moon to somehow now we're talking about the speed of the rocket cars in the Salt Lake Desert, which has nothing to do with the shape of the moon.
No,
so you've hop-skipped from water is always level. You've hop-skipped to how the directions things rotate in relation to each other, to the distance that the moon travels, and now you've hop-skipped over now to the salt flats and a car moving on it. None of those connect to each other. You're not making any sense. Do you have any evidence other than...
No.
No? Okay.
No, I said, yeah, I do. I got plenty of evidence.
Okay,
what I was saying no to was that you were trying to compare... You were trying to compare the Earth to a train, but I don't think you understand the scale.
Okay, what does the scale affect?
Of the flat Earth. You don't understand how big the scale of the flat Earth is.
Okay, scale of the flat Earth has nothing to do with the train analogy, as the flat Earth is not moving.
And we're not living in a train either.
Right, we're living on the globe, and the train was an analogy to show that you cannot... The train was an analogy to show that you cannot measure the speed of the reference frame from within the reference frame. Okay, you have to have some contact with something... Hang on, you have to have contact... You have to have contact with something outside of the reference frame. Your car going east in the desert and then west in the desert does not have any contact outside of the reference frame. That's what my analogy with the train is. The train is a reference frame. I'm not saying the train is the globe. I'm saying the train is a reference frame. And you cannot use measurements from within the reference frame to measure that reference frame. Which is why we use things like the stars to measure the rotation of the Earth.
Like my original point is that it's just another one of these things where the math is made up later in order to fit the lie.
Again,
is my point.
You haven't put any math that's been made up later. It's interesting that all of the math goes towards the globe, because like if it were a globe, the math would just work anyways. But now you're saying, well, if it's not a globe, it was designed to be made up, or was designed to look like a globe, but if it were a globe, then the math would, because if it were a globe, the math would just work, right? Because like, if this were true, that's what the math would say. The math would work, right? So it's odd that the math.
I mean, if you
when we assume when we talk about the globe and we say this is what's expected on the globe, and then we look at reality, the reality is reflects what we have expected. Okay, so it's odd that every observation that we can make, every measurement that we can make, every measurement that we can make fits the globe.
Is programmed.
So okay, so now all measurements are programmed. So now you yet to show evidence. You just keep saying you have evidence. You've shown none. I
can show evidence right now. Okay. Are you in America?
Yes.
Are you in America?
Yes.
Okay. What is your unit of measurement?
I use.
Is it metric or what is it?
So I use metric because I use things for engineering and I teach engineering. So I use the metric system.
Okay, so you switched over to a new system as well too. You know why that is?
Is this proof that the Earth is flat? I don't understand how people using metric and some people using imperial is proof that the Earth is flat.
It's proof that the math is fake. It's proof that the math is fake.
Okay,
you know why?
Show me the fake math, because you're just saying things.
No, I am saying things. So the original math was foot and inches, right? Feet and inches. Is that correct?
What original math?
So the American standard was feet and inches.
What original math was feet and inches?
Arabic.
Arabic used feet and inches? Was Arabic the original math for geometry?
Arabic's all the way back to the original math, or back to the...
Was Arabic,
it's back as far as you can go as far as the math.
Was Arabic what geometry was made in?
Yeah, because Arabic is where all the numbers come from.
Okay, so they were using
Arabic is where the oldest model of the
system comes from. They were using Arabic in Greece when they were coming up with math?
I have a copy. Yeah, but my point is that originally it was in feet.
We don't use Aramaic and Arabic in math. We use Greek lettering, which is odd because you said that it comes from Arabic, but we use Greek. That's what alpha and theta and all of those
is
Greek.
Over time, science has blended shit, you know. Yeah, in Roman numerals and stuff.
Originally was Greek. Originally, it was Greek.
Yeah. But the point is the very first thing we put on the earth to measure stuff was our foot. Right? I don't care if it's Arabic or if it's Greek or Roman or whatever.
The math in the first place was Greek. So it doesn't matter.
I know, but everything comes from the foot. That's the very first unit of measurement. The king's foot.
Right, but no one actually knew how long a king's foot was. It wasn't until relatively recently that we actually decided what a foot meant. So, I'll ask you again. Did math start in Greece? Did they use Aramaic? Or Aramaic or Arabic? Yes or no?
That's my understanding of it. Yeah, that's where all numerology starts at.
So you are incorrect.
All numbers, all math.
Geometry, physics, and calculus all started in Rome and Greece using the Roman and the Greek lettering. It did not start in Arabic. It always used metric, and then when we used the standardized stuff, we switched it to feet. But if you're still using metric, then your argument is null and void. So, again, where is your evidence?
I don't know enough about that to where I'm going to try to argue it.
Why would you use it as an argument if you don't know enough about it?
Because the argument is not so much the semantics of where math started, but just the fact that math is already corrupted in the first place.
Okay, show me its corruption.
You want the evidence, dude? What's 1 times 1? What's 1 times 1? 1 times 1. What is it?
Okay, so if I have an apple and I put it on the table 1 time, how many times did I put it on the apple? To put the apple on the table.
If you have 2 apples,
listen, no. Now you're saying 2. Okay, listen to what I'm saying again. If I have 1 apple and I put it on the table 1 time, no, do not cut me off.
You know the truth.
Do not cut me off.
You know the truth.
You are so scared to answer this question. You're so scared to answer this question. If I put my singular apple on the table 1 times, how many times did I put that apple on the table?
Okay, 1 time.
Answer the question.
What? 1 times 1 is 2.
Okay, if I have an apple, you are terrified. You are so scared to answer this question. 1 apple, and I put it on the table 1 times. How many times did I put that apple on the table?
What if you cut it in half? How many apples do
you are terrified. You are so scared. You are shaking in your baby seal leather boots. You are so scared. Answer the question. If I have
1 times 1 is 2, bro. He's right.
You are so scared. You are terrified to answer that question. All right. See you later, scaredy cat. Flat Earthers.